Shri Gurubhyo Namaha, children. Welcome to our online classes. Hope you are enjoying our online teaching academy Ekalaiva. Today we are going to talk about root mean square value of AC. Now last class when we were discussing about calculating the magnitudes of alternating current which varies for every half cycle, we were discussing about average value of AC, like how we were calculating the average value of AC for every half cycle. So that was one way of finding out the average value of AC. Today, in continuation with that, we are going to discuss the next topic of calculating the value of AC, which is root mean square, or it is called as RMS value. So today's topic is, the lesson name is Electromagnetic Induction and Alternating Current. We are going to start with RMS value of AC. So what is RMS value of AC? RMS is nothing but, you call it as root mean square value of AC. So this is one method of finding out the magnitude of the alternating current. So let us first learn the definition of what is RMS value of AC. So RMS value of AC is nothing but, it is defined as the square root of the mean of the squares of all currents in a cycle. I mean, we are going to talk about one full cycle. When we were calculating the average value of AC, mean average value of AC, we were taking the value as half cycle. First we took the value for positive half cycle, then it was calculated for the negative half. That is one way. That is one method. Now here in this root mean square value of AC, we are going to calculate the value of alternating current by taking for one full cycle of AC. So the formula will be, now I will write this value of current as IRMS. So root mean square value of the current is written as IRMS. If it is going to be voltage, we will write it as VRMS. Okay ma, so the formula for this is, first let me have the square root of, I'm going to find out the squares of all currents in a cycle by the formula area of one cycle of squared wave by base length of one cycle. So this is the formula to find out the value of IRMS. Okay ma? So I read the definition once again. It is defined as the root square, which square root of mean of squares of all currents over one full cycle. Okay, so it is represented as IRMS. Okay, and we know the value of current, instantaneous current at particular point as I is equal to Im sin omega t and V is equal to Vm sin omega t or theta. We are going to use these two equations to find out the root mean square value of AC. Okay, now why are we finding out the squares of all the currents? Now look at this diagram. Now here, now this is the diagram which we have already discussed. Now this is the voltage curve, this is a sine curve. Okay, so this is the alternating voltage sine curve, right? And what is that we have done here? Again, as usual, theta is along the x-axis, and here we have taken current along the y-axis. So let us take this as a current sine wave. Now, what has been done? Now, this is the positive half cycle, and this is the negative half cycle. Now, what we have done here is, now this is the positive half cycle. Now, this has been squared. Suppose last topic we were discussing about this as the peak value. Now, here let me take this point as A, and let me take this point as B. As I told you, this is, here is the maximum current, and here also maximum current, but here in the negative direction I said. But here what has been done now here is, now suppose let me consider the value of current as I here, which is the maximum current, I maximum. Now what has been done, if you square it, okay, so I becomes I square, and the amplitude, look at the amplitude here, I squared wave, the amplitude is much more greater than the I sine curve. You are able to understand? So square of it will have greater amplitude. Similarly, in the negative direction, now here I have minus I, right? So here it is plus I, here it is minus I. When you square it, what happens? Minus I into minus I becomes plus. So when you draw the graph will be once again along the positive x-axis. Now, so when all the values are along the positive x-axis, it is very easy for us to determine the value of current. That is why we go for this squaring of current. So the sum of the squares of all the current. So when you keep on squaring all the values of the current, now this will give the area of a squared wave. So if I find out the area of one cycle squared, now this is one cycle, right? Alternating wave, alternating current wave. When I find out the area of one cycle of squared wave, I will be able to find out the value of current in this method. Am I making you the concept clear? So we use the current equation and the voltage equation once again to find out the average value or the root mean square value of AC. So it is very easy for me. Now here the direction of current becomes the same, whereas here it is changing, but when I square it, when I take the amplitude of it, this will be in the positive x direction. So the direction of current will be the same in, now here also the direction of current is, both the direction of current remains the same, although the current is alternating because I have squared it. So when I square, when I plot a graph, it will be along the positive axis. So I can find out the value of current through this method also. So to find out this, I am going to take once again a small elementary strip once again here. Look at this diagram once again. This is again a small elementary strip. Now here the angle is taken as d theta and the squared current. So this will be I square. So let me start writing the area of the element. So I will start from here. Area of the element. Area of the element is I square d theta. Look at the diagram once again, children. So here it is breadth, here this will become the length. So it is I square. Now this is the maximum value, right? So this is the measurement. So it is I square d theta. So area of the element is I square d theta. I'm going to find out area of one cycle of squared wave. Squared wave is equal to, now I am going to integrate, but this time I am going to take the full length. Look at the diagram. I am going to take this full length from 0 to 2 pi. Remember when in the last topic we took for the first half cycle. Now here we are going to take for the full cycle, which is from 0 to 2 pi. So the limit that I'll be taking is from 0 to 2 pi with I square d theta inside. Okay, now let me write the value of current. I is equal to Im sine omega t, and what is voltage? V is equal to Vm sine omega t. This can also be written as I is equal to Im, instead of omega t I can write it as theta also. So it is Im sine theta. Okay, now let us find out the area. I will just write in short, children, area of, okay, otherwise I'll write one cycle of squared wave is equal to integral 0 to 2 pi. Instead of I will substitute Im sine theta. So this equation will be Im square sine square theta d theta. Hope you have understood this. Clear? Is it clear? So can I proceed? Now here I am going to take this value is constant. So I am going to take this out. So Im square will be out. So I have integral 0 to 2 pi sine square theta d theta. Okay. Now I have the formula for sine square theta. Trigonometric formula. Sine square theta is 1 minus cos 2 theta by 2. So substitute here. So when I substitute, now this is a formula. So let me have a box for this. Now once again this equation. So area, I'll write in short here, area is equal to Im square. Now I'm going to substitute for sine square theta as 1 minus cos 2 theta by 2. Now I'll put this in bracket d theta. Okay ma? Now let us go for the integral part. Now here also 2 is constant. So that also let me take it out. So numerator I have Im square divided by 2. Now bring. Now let me separate. Now this d theta has to come inside. This 2 has come out. So d theta minus cos 2 theta d theta. So let me write it separately. Now here again integral 0 to 2 pi d theta first. Okay. Minus again integral 0 to 2 pi. I have cos 2 theta. Now close. Cos 2 theta d theta. Sorry. Okay, so what is cos 2? When I integrate cos 2 theta d theta, I will have sine 2 theta by 2. Hope you are very familiar about this, right? So simplify once again. So this I will have Im square by 2 integral d theta is theta. Okay ma? Minus what is cos 2 theta d theta? It is sine 2 theta by 2 with the limit 0 to 2 pi. Okay. Now I am going to substitute the limits. Again Im square by 2. First let us substitute upper limit for this theta and sine 2 theta. So substitute theta instead of theta. I will have 2 pi. Okay ma? So 2 pi minus sine 2 into 2 pi by 2. Now this is for the upper limit. Minus substitute lower limit 0. Theta instead of theta substitute 0 minus sine 2 0 by 2. Close the bracket. Okay. Now sine 4 pi I will have here. Here also sine 0. So sine 4 pi and sine 0 will have the value 0. So this term will not be there. Already this is 0. So what alone is remaining? 2 pi alone is remaining. Okay ma? So I will have Im square by 2 into 2 pi. I can also write this as Im square pi because 2 gets cancelled here. So this is nothing but area, right? Im square by pi. Now I'm going to substitute this for calculating IRMS. So what is the formula for IRMS? Look at this formula. Area of one cycle of squared wave that I have found out now divided by base length of one cycle to the square root, right? So I'm going to substitute here. Let me write square root Im square pi divided by, what is the base length I said? Base length is 2 pi. So here also pi gets cancelled. So I have Im square by 2. Now Im square inside root, when you take it, it will become just Im, right? So IRMS is Im divided by root 2. So this is the root mean square value of current. Now I can write the same equation for voltage also. I can write, let me write here children. So what is a voltage equation? It will be VRMS equal to Vm by root 2. Remember, all these formulas are used for numericals. That is why I just specifying on these formulas. Remember these formulas, it will be used in numericals. Okay ma, or Im is equal to or IRMS equal to Im by root 2. Root 2 value is 1.414. So I'll have the value for IRMS as 0.707 times Im, which means for a symmetrical sinusoidal current in the form of a sine wave. Okay, so for a symmetrical sinusoidal current, RMS value of current is 70.7. When you convert this into percentage, this becomes 70.7 percentage of its peak value. Im is the peak value. Similarly, I can write this for voltage. VRMS is equal to 0.707 Vm. Okay, so this is a very important 5-mark question in your textbook children. Okay, very important 5-mark. And the last value and the last topic which we were discussing, that is mean or average value of AC, that is also a 5-mark question. Okay, so remember to learn this 2 concepts, right? Very important topic. Now with this we are moving on to the book back numerals. Now this is your book back sum. I'm going to discuss 3 sums from your book back, so please make a note of it. So let us start with this sum. A closely wound coil of radius 0.02. So radius is, let me write down the datas, 0.02 meter. Okay, with this I can find out the area of the coil. So area of the coil. What is the formula for area? Pi r square. So pi r square 3.14 into 0.02 the whole square. So when I simplify this, I will have the value to be 1.256 into 10 power minus 3 meter square. So I found out the area. Now this is placed perpendicular to the magnetic field. Perpendicular. Okay, I'll come to this later on. When the magnetic field is changed from 8000 Tesla to 2000 Tesla. So magnetic field is changed. So let me write this as dB. Change in magnetic field is 8000 minus 6000, which is, what is 8000 minus, sorry, 2000, which is 6000 Tesla. Okay, time is also given. So it is changed from 8000 Tesla to 2000 Tesla in 6 seconds. So dt is 6 seconds, and EMF is induced, which is 44 volt. Okay ma, now what is that you should find out? I have written only the data, so you need to find out the number of turns in the coil. Okay, now what is the value of theta? So theta value is found to be, now what is that they have said? A coil of radius is placed perpendicular to the magnetic field. Now look at this. Let this pen be the magnetic field. Hope you are able to see this children. This pen is the magnetic field, or let me keep like this so that you understand better. Okay, magnetic field, and I have taken the coil. Now this coil is placed perpendicular to the magnetic field, right? If this is going to be the perpendicular to the magnetic field, what about the normal of the coil? The normal also will be like this. So what is the angle between the magnetic field and the normal? Normal is always perpendicular. Consider this to be the normal, okay, to the normal of the plane. So this normal and this magnetic field, they are parallel to each other. So theta will be 0. This we have already discussed in orientation of the coil. So you have to analyze the, why I am showing is, whenever some information is given in the numerals, it is for you to understand it very clearly and write the values according to that. So if it is placed perpendicular, in the sense you need to consider the value of theta to be 0, okay, or 0 degree. Is it clear? Is it clear? Now let us move on to the sum. Now first, actually you need to find out the number of turns, but you have to write the formula for induced EMF of the coil. So induced EMF of the coil. What is the formula? You know the formula. E is equal to, actually it is BA. Okay, it is BA cos theta. But here you need to know the number of turns. So it should be NBA cos theta, and A is also given, but dB by dt. B is not given directly. They say that the magnetic field is changed from 8000 to 2000 in 6 seconds. So it is dB by dt. Okay, cos theta. Now cos theta 0 you substitute, cos 0 becomes 1. So the remaining values I should substitute, but what is that I have to find out? I have to find out number of turns. So rearrange the formula. So N is equal to E by, you have all the other values in the denominator, N into dB by dt cos theta. Okay ma? Now I am going to substitute all the values. Now this is equal to EMF induced is 44. Okay ma? Right? Now here, sorry, N will not be here. Here it should be A. Sorry children. So it is A. N has gone to the left side. Okay, so it is E by A into dB by dt cos theta. So what is A? I have already found out the value for A, which is 1.256 into 10 power minus 3 children. Then dB by dt, 6000 divided by 6 is 1000. Okay ma? Into cos 0, 1. So this will be 44 divided by 1.256. Here it is 10 power minus 3. 1000 is 10 power 3. So this gets cancelled. Okay. So it is 44 divided by 1.256. You have a denominator. You have in the denominator a decimal number. So make it as a whole number. So multiply by 1000. 1000 here, 1000 here. So you will have 44,000 divided by 1256, right? So when I divide this, I will have approximately the value of number of turns. So what is the value of number of turns? It will be approximately 35 turns, which is the answer. Okay. Hope you have noted this down. Next sum. We are moving on to the next problem. A rectangular coil of area 6 centimeter square. Okay, so rectangular coil of area. What is the value? 6 centimeter square. So immediately convert it into meter. 6 into 10 power minus 4 meter square. Okay ma? Then number of turns is given. N is equal to 3500 turns. Is kept in a uniform magnetic field. B value is 0.4 Tesla. Initially the plane of the coil, it should be plane here. The plane of the coil is perpendicular to the field and then is rotate. Initially the plane of the coil is perpendicular, which means in this case theta is equal to 0. Then perpendicular to the field and then it is rotated through an angle of 180 degree. Here theta is anti-parallel, theta is 180. Okay, so you have to find the difference of theta here. So understand the sum properly here. Here it should be theta. Previous sum, magnetic field was changed, dB by dt, but here theta is changing. So we have to take theta 1 minus theta 2. So initially theta 0, finally it is 180. Okay, if the resistance of the coil is 35 ohm, find the amount of charge. You should find out the value of charge. To find out the value of charge, I know the formula for charge. Q is equal to I into T, right? I should know the value of current. So to find out the value of current, I should know the value of induced EMF. So first, let us start with induced EMF. So induced EMF is equal to E, which is nothing but what? Change in flux. Change in flux is EMF, right? So I will have phi 2 minus phi 1. I know the formula for phi as NBA cos theta, right? So NBA cos. Now here I have final value which is 180 minus NAB cos 0 degree. Am I right? Okay, so cos 180 is minus 1, children. Cos 0 is 1. So here I have minus NAB minus NAB, which is minus 2 NAB, which is induced EMF. Now I'm going to substitute the values. Minus 2 into, what is number of coil? Number of coil N is 3500. 3500 into area. Area is, what is the value? Area value is 6 into 10 power minus 4 into magnetic field is 0.4. Okay. So when I simplify this, I will have the value to be 16800 into 10 power minus 4. So bring this 10 power minus 4 inside. I will have minus 1.68 because I have a negative sign. So that will be followed everywhere. So this is induced EMF, which is volt, which is measured in volt. So I have found out induced EMF now. Now I have to find out the value of current. So current I is equal to V into R. This is nothing but current. Okay, so I. So substitute here V the E here. So I is equal to minus 1.68 into, what is the value of resistance? It is 35. So multiply this. Sorry, I is equal to V by R here. So it is 1, why it is division. Okay, 1.68. I is V by R. Sorry. Okay, so 1.6 divided by 35. So what is the value here? When I divide this, 0.048. Now from this I can find out the value of charge, which is Q is equal to I into T. So 0.048 into time is, what is the value of time given? Time value is 1. Okay. So I have the value of charge to be 48 into 10 power minus 3 coulomb. So this is the answer. Okay. And the next sum, I'll just give you just the formula. Everything is given. I is induced current. Okay. So 2.5 milliampere. Resistance is 100 ohm. You need to find out rate at which the magnetic flux. So it is d phi by b by dt, which is nothing but induced EMF. Okay, which is equal to I into R. So I is 2.5 into 10 power minus 3 into 100. You will have 250 into 10 power minus 3 Weber per second is the answer. Okay. So work out all these three sums. We'll be continuing with the next topic in the next class, children. Okay, ma? See you then.